district. He has been with the district for about 3 years and comes from the Portland district in the US. Originally from Arizona, Jacob currently has over 15 years experience as a geospatial professional and has spent time in the private sector as a government defense contractor before dedicating himself to the Army Corps mission for the past decade. He has a passion for geospatial data and technology and enjoys working across the broad range of disciplines and challenges that intersects with the GIS, CAD, surveying, and remote sensing communities. Among the things that Jake enjoys is Sonoran-style Mexican food. I need to know more about that. Salmon fishing and Portland Timbers soccer games, and his dog Lola, the Labradoodle. Jack was published in 2021 as a co-author of Chapter 4 titled The Mouth of the Columbia River, USACE GIS and the Resilience in a Dynamic Coastal System in the following book, Resilient Communities and Across Geographies. Congratulations. And Jake was also awarded the 2018 USACE Spatial Professional of the Year as inaugural awardee. So before leaving the floor to Jacob, I'd like just to remind that if you have questions, you can post them on the chat board, or if you have very urgent questions, you can raise your hand and we can address them either during the presentation or in the Q&A session. Now, Jacob, the floor is yours. Thank you.
Okay, great. Thank you very much, Chris, for the kind introduction. Charisse, this may be yours. We'll get ourselves situated here. Good day, everybody. As Chris mentioned, my name is Jacob Watts. I'm a geographer and a project manager here with the U.S. Army Corps of Engineers Europe District. I'd like to thank you all for having me here to present some of the work that we do from the geospatial side. And kind of the lead up to this presentation, I gathered this wasn't a topic that's been covered at one of your previous gatherings, so I was grateful for the opportunity to kind of bring to light a different side of the work that we do, and hope to sort of introduce you, if you're not too familiar with what the geospatial community of practice within the Corps is engaged with. So with that, I'll get the slides going. I'll try my best to say next slide or previous slide. But here we go. So today I'm just going to take a bit of time to go over sort of the overall Corps of Engineers mission briefly. I recognize that most in this community is fairly familiar with the Corps of Engineers and the different mission sets that we have, but I just want to kind of set the table with how our geospatial community of practice fits into that overall mission within the Corps. And then get into a little bit of the policy side and the guiding documents that inform and drive the work that we do. I'm going to take a little bit of a technical turn in the middle of the program to talk about geospatial data standards, what that means, and why I think it's important. It's an important aspect of the work that we do. And then I'll kind of narrow it back down to the Europe District Corps of Engineers, our geospatial team, and highlight sort of what our mission is here within the Europe theater, and highlight some projects that we've been executing over the past 3 years, as Chris mentioned, since I've been here. And just to get started, I put at the bottom of the slide a statement that I think is important and kind of underpins pretty much everything that I'll discuss as we go through this conversation. The USACE is a data-driven enterprise, and I made the title of the presentation, Developing Products for Data-Driven Decision-Making, because that's a key focus for the Corps of Engineers at this point in time. And as geospatial professionals, our work is really based in good quality data. And so I just kind of underscore that's an idea that I'll come back to throughout the presentation, that having quality data. A lot of people think of GIS or geospatial CAD folks as the map makers, and that the final end product is what most of the decision makers actually see. But in order for those products to mean something, we have to have good quality data and good quality processes for managing that data, so that you can trust the information that we provide you. So that's the baseline. Next slide, please. So just to go high level, Corps of Engineers, like I mentioned, I think everybody in this group is familiar with our general mission. But to highlight it, I won't go through all the data points on the right side of the slide, but those are some key highlights of the work that the Corps is engaged with. On the mission side, though, I just want to highlight that we have these 6 different program areas. Big one that we're not engaged with here in the Europe district, but that is, of course, a key component to the work the Corps of Engineers does, is our civil works mission. And then the military mission is something that takes place both, on the Kona side as well as the Okona side, and really where we put our focus and energy here in the European theater. And then we, of course, have our environmental, emergency operations, research and development, and sustainability mission sets as well. So you may be accustomed to seeing those white hard hats, maybe after a hurricane or something of that nature. And the point I would drive home with this piece of the conversation is just that the geospatial community of practice and geospatial professionals in general are engaged throughout all of those mission sets and are contributing to the mission across the board throughout the Corps. So quickly, just to highlight that civil works mission that I stated, it's largely CONUS-based, but not entirely. I made a map here that I recognize nobody can read all the words on. But basically, on the civil works side, I like to think of us sort of as the water agency. Our role is to manage the nation's water resources, and that entails a lot of different aspects of engineering, from managing our navigation channels for commercial navigation, doing environmental restoration of wetlands, flood risk management, etc. That's really where the core, the heart of the civil works mission lies. And the breadth of the work that we do is just demonstrated by this map. We call it the Civil Works Wall Map, and it looks a lot better when printed out in a large format and put on the wall. But if you were to zoom in on wherever you're from or wherever your friend might live, you're going to find that just about wherever you go across the country, the Corps of Engineers is working civil works projects in nearby where you are likely from. On the military side, we have several different sort of sub components to the work that we do. Of course, supporting primarily the United States Army as well as the Air Force through our military construction programs, doing different environmental work. The Corps is the sort of the real estate office for the Army, and a big component of the work I'll describe here today is the installation support that we do. So I just put some pictures on the slide that kind of highlight some of the work that we do here at Europe District, from sort of supporting our military members out in theater to developing new medical facilities and schools, supporting the Air Force and some of the new upcoming F-35 missions, etc., as well as some special projects in the Africa continent as well. So now to get back down to sort of why I'm here and my role within this enterprise is to talk about our geospatial community of practice. And if you're not familiar with that, we're what we call an umbrella community within the Corps. And so we have these 5 different key components or disciplines that are kind of managed under this one enterprise geospatial program. Those include our hydro survey sub-COP, our remote sensing and unmanned aircraft systems sub-COP, CAD-BIM, GIS, which is Geographic Information Systems, and then of course the topo surveys. So each of those components, I could describe different work that we do. The hydro survey folks are engaged with mapping and collecting elevation data, primarily of our navigation channels, so that they can then inform our dredged materials disposal folks of when and where we need to go ahead and dredge our navigation channels to keep commerce flowing. On the remote sensing side, what I mean by that is basically doing data acquisition, typically aerial photography or elevation data through something called LiDAR. That is being performed these days both from manned aircraft as well as unmanned aircraft. And then the CAD-BIM side, of course, is focused on managing information for a lot of different, information dissemination and facilities management. The GIS group really does go across a very broad range of work that we perform and aspects within the program that we support, primarily through the data acquisition, data management, the spatial analysis, and then ultimately cartographic map production or tabular data dissemination to help provide information to decision makers. So when we talk about geospatial, basically we're within this program talking about data that's referenced to real world locations, the acquisition of that data through these different surveying methodologies and tools, and then the management of that data and using that data to create products to help inform decision making. So that's the sort of the breadth of the geospatial community practice within the Corps. And then I just wanted to highlight once again that we consider this data a corporate asset, and it's something that we are focused on within our COP is to make that data that we collect available, make sure that it's, first of all, quality data, and then when we have that quality data, that it's accessible to the people that need it when they need it. And so that's kind of where my focus on this slide is. And I just wanted to tie in with what the Corps has going in a program and a document that we call the USACE Data Strategy 2025. And this is something that has come up in the past couple of years and is underpinned by a data governance board at the headquarters level. But it basically syncs us together real tightly with the larger DoD and Army data strategies that, like I kind of underpin at the bottom, to make data visible, accessible, understandable, trusted, interoperable across systems, and secure. And so that's kind of what the data side that I mentioned in the beginning that we're striving to continually improve and be that data-driven enterprise that we intend to be. Sorry if I haven't been mentioning slides. So then I was just going to kind of quickly highlight and not go into too much detail here, but there's a fairly significant set of policy and guidance documentation that drives the work that we do. And this may be some references that some of our team members have seen, through scopes of work or references that highlight where to go find information. So this first slide is to take it to that higher level of sort of the federal government at large. The Executive Order 12906, which was originally published back in the 90s, has to do with basically geospatial data management and the intent to make data accessible across the federal government, and puts down in law or in an executive order that that's a requirement. And then there's, of course, a series of DoD and Army regulations that also underpin the work that happens within the Installation Geospatial Information and Services program for the DoD. And on the next slide, I just take that down one step further into the Corps of Engineers and highlight some of the policy and guidance documents that we have within the Corps and in the geospatial realm. So the ER 1110-1-8156 is out there, and it basically is the policy side, the thou shalt for how we do this work within this community of practice. And then underneath that is a series of what we call engineering manuals. At the top level, EM 1110-1-2909 is basically the how to implement the regulations that are found in the ER. And I was just going to highlight that I've been working on a team of late to basically update that particular engineering manual. So if you're excited for some good reading, stay tuned for 2022, early 2022. I think we'll have a new version that was last published in 2012. So I think there's some good, this is an evolving technology and way of working, and so I think we've got some good updates coming for you there. But then each of those different subcops and different surveying methodologies and systems, the Corps also has documentation and instruction on sort of how to interact with those different tools to create consistent, standardized, and quality data products. So I'll shift gears a little bit here and hopefully not get too technical, but give a little bit of a understanding of something we call geospatial data standards. And I would like to sort of introduce you to what I mean by that in the first place, and then hopefully give an example or a demonstration of why that matters. And so why is this important? I'll use two examples, one on the GIS side, Geographic Information Systems, something called SDS-FIE, and I'll get you more information about that. And then on the CAD-BIM side, we can talk a little bit about the AEC CAD standards. And I expect most of you are familiar with those terms, but I think I can maybe dig into a little more detail to help you understand more fully what that means when you read those acronyms. So to start, we'll do the SDS-FIE. So it's another mouthful, but here we go. It's the Spatial Data Standard for Facilities, Infrastructure, and Environment. So the SDS-FIE. And this is a data standard that basically exists across the DoD. It's a DoD governed standard, and each of the different components within the DoD has a seat at the governance table for how this standard has been developed, updated, and implemented. And that basically what I'll get into a little more detail, but it's setting the framework, it's setting the template for how we describe different GIS data, the information that's required to be stored within those databases, and making that consistent. So whether you're collecting information for the Air Force or the Army or the Marines, that data is interoperable and understandable across the different service components. So next slide is to just say that the primary SDS-FIE standard that most people are familiar with and typically work with is what we call the vector standard. And so I'm not going to go into a deep dive about too much technical GIS jargon, but basically there's a few different what we call data models, ways of representing real world features in a digital mapping environment. And so one of those is what we call vector data. This is data that you can think of as points, lines, and polygons, basically. And so for a given point that you put in the world, which may represent the building that we're sitting in, there's some series of information, an attribute table we call it. You might think of it like an Excel spreadsheet where there's different attributes that describe what that feature is representing. So first of all, you're going to have a location because that's what we do. But then in this circumstance, you're going to have a building number. You're going to have a usage and a series of other information, what's the square footage, etc. And so that's what that attribute table is recording the information that describes that point, line, or polygon. And so what this SDS-FIE standard is doing is making it so there's a standard naming convention for different layers, different feature types, so that no matter if you're developing this data, you know, in San Diego or in Wiesbaden or anywhere in between, we're going to all be speaking the same language. And when I pull a feature into my map, I'm going to know what that is because it's been defined in this data standard. What is the description for that feature type? What are the fields that are available to be filled out within that feature type, etc. And so that'll be available to, like I say, any user should be able to look at and understand the information because it's been standardized. And so to go into a application example to sort of just hopefully narrow into why that matters and why that's important is to look at the Army IGINS program. So again, the Installation Geospatial Information and Services program within the Army, which is charged with managing and maintaining these types of information. And so what the Army has is they kind of take it one step further. They have a series of documents for basically every feature type that exists within that, well, not within the entire SDS-FIE, but at least for what are called common installation picture data layers that every installation is expected to have to represent in a mapping format the information they have. They've developed these quality assurance plans or QAPs. And that kind of takes that SDS-FIE data standard and tailors it to the specific use case of the Army. That's sort of the MCOM installation management program within the Army. And so what they do is they define, you know, the accuracy requirements for that type of feature. They define how that information should be collected, how often it needs to be reinvestigated or recollected. And then that spatial data standard has an awful lot of attributes available within the SDS-FIE, and they kind of narrow it down to the thou shalt fields, the things that you must have filled out within your database versus the more nice to haves. And so they narrow that down and provide their geospatial professionals these quality assurance plans. And that's something that as we develop data products, now we have something to check, you know, data deliverables against. And we want to make sure that when we're receiving data through projects that we manage, that it's meeting these requirements as a deliverable product. Now, from the map side, I just thought I'd maybe help to bring that in for somebody that maybe isn't as familiar with GIS. Most of you have probably, you know, worked in there to a certain extent at this point. But the example that I put is just you know, a pavement data layer at a given installation. And the idea is that we have our real world location identified as accurately as possible. So that's highlighted with the turquoise color of a given road that's out there. And so the geometry is formed. And then the database is what's on the right side of that map interface there. And you can see, albeit it's not the attribute table going left to right, it's basically that same attribute table going down the list in this case, with all the information that describes the details of that particular road at that particular place. And so again, now we can check that database against that quality assurance plan and against the SDS-FIE to make sure that we're compliant with the Army requirements. And that comes into play in a couple different ways. Number one, just operationally, these DPWs need this information so that they have a current and accurate portrayal of the features, the real world property assets that their you know, mission is to manage and maintain and operate. And then we also have a component of this where this data set is needs to be pushed up to a higher level. It doesn't just need to sit at a given installation. The Army at large, or at least at IMCOM headquarters, on a quarterly basis needs this data to be basically uploaded and brought into what they call an enterprise GIS, an enterprise database, where now the Army can look at sort of a macro scale at the different real property assets that are managed and maintained, and having those data standards and some different program measures of ways that data is going to be checked allows them to then at sort of an installation level track the progress and the improvement of data and report out whether a given installation has a good quality geospatial data, or if there's gaps, it's able to identify where those gaps are and help put resources in the direction that they need to. So this data kind of has multiple purposes, and that's another one of our sort of data ideas, is we collect this data once and then we make it available through multiple applications and for multiple uses. And so this is what we call the data quality validation reports. And so as each installation uploads that data quarterly, these checks are run, and basically we can measure progress over time. And the last piece of this conversation is to talk about the real property reconciliation. It's basically a large-scale effort that's ongoing right now within the Army to try to bring together, to bring into synchronization these different databases that exist. So the GIS data exists to represent the real property assets of the Army, but there's also other databases such as HQIIS and GFIBS that feeds HQIIS. And in a perfect world, what we see and show on a map would be a perfect representation of what's in HQIIS. And more importantly, both of those would represent what's actually out there in the real world. But we don't live in a perfect world, and there's challenges, to gathering and collecting this type of information and in managing and maintaining in a dynamic environment that we live and work in. And so this real property reconciliation is a program that's going strong right now, and trying to utilize the information that we have in the GIS database and compare that against what's in HQIIS, and then be able to report out when it comes to actually funding these DPWs for their O&M mission. They use that real property information through something called a facility sustainment model to inform how much resources are allocated where. And so when there's discrepancies, it's a really helpful tool through the GIS to be able to make map books and produce information that shows, hey, we just surveyed this, we have it in a map, we can show you that we have X, Y, and Z, real property assets. Now we can give that to the real property folks and then work together to make sure that their database is as current and accurate as possible, and then hopefully live in an ecosystem where that information is exchanged in both directions, so that as they can inform the GIS data, and the GIS data can then inform the HQIIS, all of which is to, again, give better quality data to make more well-informed, data-driven decisions. So that was on the GIS side. The CAD side, I'm not sure, I didn't watch the clock, so somebody give me a flag when I get to the 15-minute or some odd amount of time. I'll try to move through this one a little bit quicker. We have about 30, good. I think we're doing okay. So on the CAD BIM side, there's also a data standard that exists, and again, the purpose of that is to help make products that are delivered standardized, so that different entities can pick up and use that CAD product or that BIM product and be able to ingest it into their system, read it and understand it in a straightforward manner. And so the AEC, the Architect, Engineer, and Construction CAD standard, basically does a lot of work for us in that it sets basically, it outlines exactly how the different data layers, again, much like the SCSA FIE, what are we going to call a given layer? And it tells us, not just what we're going to call the layers, but how we're going to name our file folder systems and manage the information side. It also gives us an instruction as far as how to symbolize different features within CAD drawings so that, again, somebody can pick up that map, whether it was produced in any given, either in-house or at a given contractor, and that information will be understandable and accessible. That's what we strive for, at least. So there's a website you can go to. It's called the CAD/BIM Technology Center. That's driven out of the Corps of Engineers Engineering Research and Design Center, and you have access to downloading these different data standards, and they're good things to get familiar with if you work in this environment. And another thing that we call ERDIC, the Engineering Research and Design Center, through this CAD/BIM Technology Center provides is something they call the AEC Workspace, which is a real helpful tool in that it takes what are those many-page PDF documents of the standard and brings it into basically an application that you can pull into your CAD system, and most of those standard naming conventions, file folder setup, symbology is sort of pre-set up for you. So that's what they call the AEC Workspace. And if you have folks working, in a CAD environment, I think it's a good idea to get familiar with that when doing projects, not just for the Corps of Engineers, but this is a data standard that also is utilized throughout the Department of Defense. And then the last slide on that kind of subject is to say that they also have, we use the term these days on the design side within the CAD/BIM realm of advanced modeling as a term that maybe the industry hasn't hooked into too much yet, but you'll see it in some of the Corps of Engineers documentation and here on the CAD/BIM Technology Center website. And so they have a real good template. This may be more on the project management side, if we have any other PMs out there, that helps give basically a project execution plan for how to set up and organize and manage these geospatial design projects. And so that's a real good resource for you to take a look at. And then sort of on the back end, they also have a real helpful tool called the Advanced Modeling Submittal Review Checklist. So when we are then receiving these products back, we can use it in a standardized format, this checklist, to kind of make sure that the different deliverable products throughout a project are being delivered as they should be, and hopefully in a standardized way, whether you're working for one district or another. Again, this is out there as a resource, and I just wanted to highlight that it exists, and I think as time goes by, something we'll all continue to get to working with more. Okay, one little quick drink of water here.
Do we want to see if there's any questions?
Yeah, that's good. Yeah, please. This was kind of my halftime break. We'll shift focus again here, but yeah, please, if we have a question.
Yeah, we actually do. We have one question from Michael Thomas. It's about back about in 2005, the Theater Geospatial database as was conceived. Whatever became of it? Where do USARE units get their authoritative GIS data currently?
Okay, thank you for that question. I think that this is a good kind of break point that I think I can highlight the work that we do versus some of the work that happens on the warfighter side of the Army. And so I think the question is directed more towards how is the data managed in sort of the combat areas, as opposed to the more IGINS community that I've been describing. So I don't think I have the answer to that question. The Corps of Engineers, at least through my experience, is not supporting and managing and maintaining that geospatial program on the warfighter side. And so I think that question would be probably more well suited for one of the Army component geospatial cells. So I'll just leave it at that, and maybe we can move to the next question.
Okay.
Sure. Yeah. This is from Darius Hensley, and the question is, has the Army SDS-FIE data been fully migrated over to the latest version of SDS-FEI?
Okay, thanks, Darius. Yeah, it has. The latest version, as you guys probably know, these things continue to change over time, and hopefully improve continually. The Army is now operating under what they call the SDS-FIE 4.0.2 Gold adaptation. And so that's been implemented, and as a requirement, each of the different IGINS components by this point in time should have migrated to that standard. It's good to highlight that. Just keep in mind that it's not just an Army standard, and that the Air Force also has their own, and I won't get it right if I say exactly what the version is there or within the Marines or the different components, but they each have their own kind of slightly tweaked version of that larger SDS-FIE data model. Yeah, we had them listed there before. And so when you go into the SDS-FIE webpage, you can then actually select through a drop-down list, which do you want, the latest version or the previous version, and for which component, and then you can generate the data model to go populate from there.
Chris has a question, if you can speak loud enough, or?
It's essentially the same question that we just asked.
Oh.
With regards to the joint service standards, and the fact that, it just introduces a level of complexity at the joint level where you've got separate standards in each of the services. Just, I guess, maybe in a chase up, from your assessment, are the standards relatively close to each other so that there's not a lot of variance? Absolutely,
yeah. I would say that the overall SDS-FIE data model is highly consistent from component to component. There are different criteria or different information types that are important to different components. And so that's where they've kind of taken that general framework and shaped it a little bit more refined to the actual information that's required, to manage and maintain an Air Force base, and that may have some different information associated with it than, say, an Army installation or something of that nature. So yeah, highly similar, same basic data structure, and same way of accessing all that information, but some deviations based on the work that they do.
There is one last question, at least for the first batch, is related to metadata and your geospatial environment. You mentioned as the SSFIE and so forth. So there are specific requirements that your team is asked to contractor for the collection, management, and reporting of such metadata, and how important are metadata in the geospatial environment?
That's a great question. Chris, who asked that question?
Yes, I didn't want to take the credit for it.
Oh, okay, sorry. Chris, great question. Metadata, I should probably describe what it is, but before I do that, I'll just say it's absolutely critical. It's basically the backbone to what I've been describing as having quality geospatial products and having data that you can trust when you pull it in and use it to make decisions. So metadata can be described as basically data about data, okay? And so what the metadata is the background information for a GIS or in this case, a geospatial data set. So we may have collected a whole feature class that shows us the different buildings here at Clay Caserne, which uses that attribute table to describe what building number, the location, the use, etc. The metadata is what sits behind that, we call them feature class, and allows you to understand actually how was this data collected, when was this data last updated, who was the last person that worked on that data set, and things of that nature. So it's real easy to make a map and put some pretty colors and dots on the map, but if you don't understand how that data was collected, what the currency of it is, and those other types of underlying information that you might read in a report. If you're a non-spatial data user, you may get out the project report and be able to read about that. But in the GIS database, that's basically another component to a quality data set, is that you don't just have the information, but you have the metadata to describe the quality and the other aspects of the data that you're looking at. And so, long story short, is it's most absolutely critical and important to have confidence and utilize data to make decisions, is that that sort of background information that I just described. So, Chris, hopefully that answers your question.
Yeah, thank you. Oh, well, just so about standards that the contractors have to apply. Are there, do we have to use the engineering manuals, or there is any other standard you apply?
Let's see. Well, I guess it could vary from project to project. It should be something that's described, when we come out with a statement of work or work specifications, the standards that are going to be required should be defined, and to an appropriate level. I think there's a professionalism that also exists within this community, and our both government and contract partners. Most of this is not new. This is all bit stuff that's been done before, and as it has been required for years. So most people are familiar with it and have worked within that realm previously, but it's certainly something that needs to be defined. What version of SDS-FIE, what coordinate system, what level of accuracy is required for a given data set, what metadata fields are going to be definitely required, or what metadata format should be applied. Those are all things that, definitely should be tracked and thought about when developing a geospatial project. And hopefully your scope of work helps define that. Sometimes it may not be in the scope, but it will ask that we discuss this explicitly with you as a subject matter expert, say at a kickoff meeting with our stakeholders as well as our contract partner, to make sure that we make those right decisions. Because albeit it's all been around for a long time, things do change, and it's good to make sure that we're producing products to meet the needs of the stakeholder at this point in time. So, Chris, with that, I think I should probably get moving, because I do want to have a little bit of time just to highlight some of the work products that we've been engaged with here in the past couple of years, but I have a couple more slides to get through before we do that. So I'll keep it moving, and then we can hopefully have a little time for any additional Q&A come to get back into this next section. So back to the slide deck. I just put this here to kind of highlight the Corps of Engineers Europe district relative to what we may see at other Corps districts really around the world, but specifically CONUS. The Europe district has a very large footprint, very large area of responsibility. We also have basically the largest and most strategically significant workload. These are our bullet points that I like to carry forward from our previous commander. I think he had a geographer in him somewhere. He liked to describe the breadth of the work that we do by just reminding people that our area of responsibility is over 6,400 miles from north to south. We do work in 4 time zones, east to west, and that introduces lots of opportunities and, of course, some challenges along the way as well. So that's just sort of getting us back into the Europe district. And then my geospatial team. I like to use the information on the left hand of the slide because I think it helps to describe what our job is, what we're doing here. And so we work under the program and project management division at the Europe district. So we're project managers first and foremost. We do manage and maintain the in-house sort of geospatial capabilities for the district, but our bread and butter is project management. So we sit in PPMD, and then at the branch level, we're in the installation support branch. So almost all, but not all, of the work we do is to support, Army and Air Force installations. So I think that seat in the organization, again, kind of helps describe the work that we're performing through this program. And then we, again, sit within what we call the Regional Planning Support Center, or our planning section. And those who attended this meeting last month, I think you had a nice engagement with our supervisor, Shanita McConis, that probably gave you more detail about what that Regional Planning Support Center does and our role here within the theater. And that gets us, again, back to our geospatial team. And I think you can kind of think of it as we're out there gathering this information. We're conducting surveys. We're building GIS data. Kind of goes down two tracks again, in the sense that we are collecting that information for current projects and operational utilization of that data, but we're also managing and hopefully maintaining that data so it's available to the next project that comes up, or when we need to do a future plan, that we have this geospatial information available for those planning projects. So that's the idea of the work that we do. I don't think we need to go into this too much detail. All of you are familiar with the core and our process as far as life cycle project management. But again, we're managing from basically the initiation and the scope of work development, contractor selection, then actually executing the projects, helping with logistics, doing quality control, quality assurance on product deliverables, and then delivering the products to our stakeholders, and then working the project closeout on the contracting side as well. We currently, within our planning section, we operate under two primary contract vehicles here within the Europe district, doing the geospatial work. The first one is called our Geospatial Services Architect Engineer contract. That is a shared capacity contract by 6 different contract teams, and has a capacity of about 49 million over 5 years, of which we're, I guess, about halfway through that period of performance on that contract now. And then we also utilize what we call the Master Planning and Design Services Architect Engineering contract, that we utilize when we're doing more planning studies or things of that nature that also include a strong geospatial component. And then we also have been looking into for some of the geospatial work that's not necessarily architect or engineering specific. We're looking at the GSA multiple award schedule for some of the professional, non-personal services work that we accomplish out here. So now we're going to get into some project highlights. Therese, can you give me a clock check so then I'll know?
15 minutes.
15 minutes. Great. We're in good shape. So the first project I was going to highlight is work that we do really across the IGINS, the USARA community, at different installations at different times. But this is a product type or a project where we, in many cases, help to staff or put a geospatial professional on site to work within a Department of Public or Director of Public Works office to basically further their geospatial program and fill gaps where maybe in-house resources aren't available. So we're doing a lot of work to gather the data that exists and understand the gaps between the data that exists and the data that they're supposed to have, and then help to bridge those gaps. So they're doing a lot of data maintenance, a lot of data creation and management, both in an on-site capacity as well as off-site at their own facilities. In many cases, we're helping with sort of the two sides that I keep coming back to. One side is operational, helping these operations divisions and master planning divisions execute the work that they're doing today, but also managing and maintaining that data so that it can be pushed up into the larger IMCOM headquarters enterprise data systems, so that we not only can track, like with the colorful spreadsheet where we're just figuring out who's doing a good job or who could be doing a better job with the maintenance of their data, but also publishing that data out through web maps and web portals, so that, you know, they now have what they call the Army Installation Geospatial Platform, the AIGP. It's a mouthful. And that's a real great website where a lot of those quality assurance plans and a lot of that policy documentation and things of that nature are stored there. But they also have a wide variety of web-based mapping products that you can use to investigate a given installation and help find the building that you need to get to for your next meeting, or analyze some of the discrepancies between maybe databases that are developed on the Corps side versus within the Army, different things of that nature. So again, that data gets pushed up once and then can be used for multiple purposes. The next project highlight that I have is to just talk about sort of the site, and we'll get into utilities, but basically the topographic surveying that is required to continually have quality map data of the existing real world conditions. And so we do a fair amount of survey work to go out and collect different site features, especially when we move into maybe a new shared base where that data hadn't previously existed, or take on a new installation. Then we go ahead and collect that data and make sure that it's formatted into those different spatial data requirements. And another aspect of that is what we call the real property inventories. This isn't something you may be hearing about out there across the Army at large right now. There's a big push to basically have updated and accurate real property records. We talked about the reconciliation side. That plays into this audit readiness. So they are operating under some looming deadlines to make sure that all that data is collected and in place. And so that's something that we also have been contributing to through some of the projects that we've been executing. And then on the utility side, I have two different slides. I'll start with this one. We have been performing a fair amount of what we call subsurface utility engineering surveys, SUEs. I got the words mixed up on the slide, but basically, especially when we do move in or join partners with some of our host nation allies, there's many cases where there is not quality information about the utility networks. And even at bases where we've been for quite some time, in certain cases, there's not great information about the utilities, especially underground. And so we've been working these projects, in this case was in Romania, to basically do a real thorough topographic survey as well as a utility survey to generate the accurate geospatial locations as well as the associated attribution with all the different utility sites or utility types that are present on that site. And we like to think that doing this type of work, yeah, it's time consuming and it's costly up front, but it basically pays for itself over time because your cost can quickly be recouped when you go out to do your next construction project and you don't hit that gas line that stops everything or that things of that nature, right? So having that data available helps on the planning side and it also helps on the construction side. So those types of data typically pay themselves off pretty quickly. And then the next side with the utilities is the condition and capacity assessments and studies. And so we've been working quite a bit in this realm also, now that we have that data collected, or in many cases collecting that data and then doing the condition assessment, and then basically performing a planning activity to look at what are the future use plans for this given installation, and what are the existing capacity of the utility networks relative to those future use requirements. And so we've been, again, performing that at multiple different Air Force and Army installations to help, make better plans for the future. Another highlight, I just like this one because it's a nice map product, but also was a useful tool. This one was to do with basically doing a very detailed survey of the road infrastructure at one of our garrisons, and then mapping the existing condition relative to a standardized scale as far as, good quality road, not so good, or bad quality road, and then putting that into a map interface where they could then visualize it, number one, but then look at that data and help to inform their decision makers as far as where to prioritize the resources. And then the second to the last project highlight is to talk about the facility space utilization efforts. And this is something that also has kind of gained new steam. Well, it's again been here for a long time, but gained some new steam, and is being recognized both within the Army and the Air Force as a critical requirement of managing, maintaining, and understanding the current space utilization within the different buildings that they have. So on the Army side, they have a system that's called E-Prisms. I won't go through all that acronym, but you can read that one. This is more of a CAD-based system, where we're collecting basically the different category codes, the different units that are in a given building, the different dimensions of that building as it currently exists within the interior, and then loading that information into this E-Prism system, which is an enterprise data warehouse that also can sync up with some of the other real property management systems that the Army has. And so the E-Prism system is what we've been both doing the surveying to collect that information, and then developing the products to be uploaded into that system. And then on the Air Force side, they're basically, it's kind of interesting. People find different ways. They have the same problem set, and they develop slightly different ways of solving that problem. It's kind of one of those things I like to think of when we travel around the world. People have the same types of problems, but over time they've developed different ways of solving that same problem. That always clicks in my mind a little bit when thinking about this Air Force facility space planning and optimization toolkit that they've built. And they've got something called the FSOP playbook, which is really just getting kind of out there in the current time frame. We're working on some of the first major projects to utilize that playbook. But again, it's about space utilization. It's more managed on the GIS side as opposed to the CAD side, as it is in the Army. But this is a fairly prescriptive process for how this information should be collected, managed, maintained, and then they like to take it the next step further and sort of develop some planning products right within that FSOP playbook. So if you haven't gotten familiar with that as of yet, I think that's another one of those things that you might be interested to go out and take a look at and sort of get familiar with on the Air Force side, because that's how that work will be accomplished going forward. And so the last project that I'm going to highlight, or a series of projects, which kind of fits closely within my background from some of the work, like Chris mentioned, I came from the Portland district, where we're a civil works district, and we do quite a lot of remote sensing data acquisition. And so out here in the European theater, this is kind of my one deviation, or our group's one deviation outside of that installation management area. And so we've been working with something called the ITAM program, the Integrated Training Area Management Program for the Army. to basically collect very high resolution aerial imagery and elevation data through LiDAR of quite a lot of different host nation sites in the Eastern European areas of the theater. And the reason we've been doing that is there was a shift in how the Army does training. If you get back into the 2013, 2014 timeframe, where there was kind of a shift towards the Russian focus with the circumstances in Ukraine and Crimea. Well, the Army training program, which historically was based specifically out of Germany, we started to utilize and partner with host nations and then more on the Eastern Bloc to do Army training. And so to collect high resolution imagery and a very accurate elevation data of these large training sites before we go out and actually start to utilize them has been a really powerful tool in basically setting a baseline for what the existing condition was before we came and did any of our training activities, but also having that elevation data to be able to help plan the different maneuvers or types of work that are going to happen out there. So again, we've been performing that data acquisition over the past 3 or 4 years and have developed a pretty significant database of imagery and elevation at a lot of different training areas. So that gets me to my conclusion, and I was just going to go ahead and debrief what we just talked about since you've been hearing my voice for a while. When we started, I talked a little bit about the Corps of Engineers at large, highlighting our civil works mission as well as our military mission, and trying to kind of build an idea of the work that we're doing out here at the Europe District Corps of Engineers versus what may be happening at other Corps of Engineers districts that you work with. I described our geospatial community of practice and how we kind of thread between all the different subcomponents of each of those missions. There's a geospatial application or a geospatial problem to be solved across that breadth. And we have these different subcops from hydro survey, topo survey, remote sensing, CAD and GIS that kind of bring the talent and the capability to that broad range of our mission. Highlighted some of the policies and the guidance that underpins the work that we do, and left that as more or less just a reference for you if you'd like to look at those. It's not an exhaustive list, but some of the key driving documents for how we do the work we do. The data standards, we took a pretty good look at the CAD and the GIS data standards that exist, and hopefully help you to understand a little bit better what that actually means and why it matters. And that was the key takeaway there is, we need to have quality data. It needs to be interoperable and understandable across systems and across locations, and having those data standards facilitates that. Then I talked a bit about basically Europe District at large and narrowed us down to actually our geospatial team and kind of described the work that we do through that organizational hierarchy that we have at the district: project management, installation support, planning, and then all this geospatial product development. And then we got into some project highlights that we just did a minute ago, so I don't have to run through all those again. But with that, I think that's more or less what I had for you. If there's any questions or comments or further discussion, then I'd be happy to engage with you. I see one in the back, Chris, before we...
Good. Thank you for thank you, Jake. That was very good presentation, and also meeting the time for your presentation was really awesome. Thank you. So there is a question in the back, as I understand, right?
Yes, and his name is also Chris.
Okay.
Chris, you have a question?
Yeah, I do. So I actually have a couple of them, but I won't capitalize, catch you offline. So being an Air Force guy, I would actually first off say that the Army approach to this stuff is foreign. So I like how you do that out there. So anyway, the question I've got for you on this is, especially as you went through the project highlights, you're talking through the different digital products that are being collected, surveys that are being et cetera. Is this a move towards eventually getting to digital twins of the installations, if you understand that concept of literally having the installation in a digital environment?
Oh, I got you. Okay.
As opposed to just these kind of random acts of touching as we collect data for this system or that system. It gets uploaded into web maps and GIS, and the Air Force has got its own system, et cetera. I can see a point where eventually all that data has been collected, a move towards putting it into a digital twin type of a construct, which is something that's being seen increasingly in basically out in the big world. Is that any kind of discussion going on at all in the USACE space around that kind of concept?
Yeah, absolutely. So that goes into what that term BIM that I kind of dropped a couple of times, building information modeling. That's kind of what you're describing. You use the word twin, but basically pulling all these different information types into a single interface, and then being able to model that. I would say that is definitely something that at the higher level Corps of Engineers on the policy side is something that is required and should be continually getting worked toward. But I will say that we, not just the Corps, but just the evolution of this data generation, maintenance, creation, it's a lot of work, and it is ongoing. It's an ongoing process. So I think maybe what you described is hopefully where things are headed. And they have something called a common installation picture, a KIP on the Army side, where at least they're identifying those specific elements, those different feature types that are required for every installation to have current and accurate data for, and then bringing that into a system and the GIS side. But I think the idea is there to pull all that together, but it's probably not there yet. And there's always work to do, I guess.
Thank you. Any other question from the audience, the live audience, or in person, I would say?
I have a stupid question. That's a lot of systems. And do they all talk to each other? I suspect the Air Force and the Army don't talk to each other, but.
No, I'd say they don't. And I think it's a similar kind of question that we were just discussing,
talking, yeah.
The Army, at least I know more on the Army side than the Air Force side, but of course there's a lot of different sort of databases and silos of information, and there's little interconnection between these different systems, whether it's GFibs to Builder to Paver to ePrisms, etc. They're managing and maintaining a lot of the same type of information, and hopefully building in some unique identifiers that allow those databases to be connected together.
Yeah. So what happens on these joint bases?
One of the services has lead.
Has the lead. Yeah, one of the services. Got it.
So I guess that is to say, no, there's maybe not all of them are talking to each other, so to speak, but hopefully through having those data standards and having quality data, then it becomes interoperable because you can tie them together.
That's the key, the interoperability. Yeah.
I have maybe a quick question related to the quality. And, obviously we have a number of systems, between whether it's BIM models or AEC CAD standards. What does the Corps do to ensure consistency of deliverables, whether it's design build or AE work? Do you run automated checks as part of that, that you give feedback to the AEs and delivery?
Well, we do have, like I mentioned, that advanced modeling checklist. Can't speak that it's being utilized everywhere all the time. I think this is relatively new and something that we're, working to better implement. On the GIS side, there's some good automated tools for quality assurance and quality checks, data validation and verification. And there is on the CAD side, I'm not going to lie, I'm not the world's greatest CAD expert. And so I don't want to speak at large for the Corps of Engineers as far as CAD, data deliverable, and QA checks. There are systems out there and automated processes that I know exist. I'm a little bit more rudimentary in my ability to utilize those, so I go back to the standard and do a lot more paper turning and personal checking. But I don't think if you had a CAD professional up here, he'd give you a better answer than that.
Just a follow-on comment about that. So a lot of times we use a BIM model to generate our designs, but the deliverable is in CAD, right? So then we're exporting, a very data-rich file into these flat DWG files to comply with the submission requirements. But I know for sure we don't follow any like CAD standards when we're exporting from the data-rich BIM model. So I can understand the question. We're probably in violation.
Yeah, so I sent in Korea as part of the Yongsan program there, and I was part of the PMO, and part of the PMO's role at the time was to ensure compliance. So we had a CAD compliance person that took all of the files, ran automated checks against all of them. And again, that was really before BIM. These were just CAD files. It was a huge effort to get everybody to be compliant. And I guess what I'm looking at is with the move towards digital twins and the idea of getting things where you have to have consistency, that just becomes more and more important. And I haven't seen where we've done any sort of, here's a compliance tool that looks across a standard BIM model that says, show me that you're compliant. We run checklists, but it seems like that needs to be at some point, if we expect it to interoperate, you're going to have some sort of automated checking to make it work.
Or a deliverable of the Revit model, because there's a lot of lost information where they're just slicing it into DWG files.
Well, if you'd like some more information, send me an email after this, and I can at least connect you with some folks at that CAD BIM Technology Center that will, I think, give you a more complete answer that helps solve that.
Right.
And I have a question that ties in with what has been asked and discussed right now. One is related, how your team works and interacts with the geospatial teams at the garrison installation level, because to maintain the consistencies and ensuring compliance, especially if you work across Army, Air Force, and other components. But also the other side is, what about the host nation when you have joint bases and their standards when it comes to CAD, but also GIS, and maybe a restriction that they have on certain, diffusion of data, or and then another layer on top of that, you mentioned about the unmanned aircraft versus aircraft lidar and surveys. How much of the unmanned aircraft surveys you think it's allowed then in the future because of maybe security problems? So it's a complex question, but I hope it helps to shed some light on it.
Okay, I'll do my best, and you can remind me what I forget by the time I'm at the end. The first question was about how does our geospatial team here at Europe District interact and work with our stakeholder garrison and Air Force geo-based partners. We work very closely with them, and it all depends on the specific project and the requirements that are had for that project. But we work basically all of these projects as something we call a product delivery team, a PDT, and that PDT relies on your side of it as our contractor partner. It relies on our stakeholder and the folks that have the requirements and have the funding that is being utilized to meet those requirements. And then us here within the Corps of Engineers who are executing the contracts and helping to manage and move projects forward. So that PDT, we work closely with all sides of it as sort of from the project management stance in the middle. And so when it comes to working with our partners and our stakeholders out, on a given project, then we're going to work closely with them, what you could think of cradle to grave, basically, because this work is being performed at their request and on their behalf. And so we need to make sure that we understand the requirements that they have that we develop scopes of work that will produce products that meet those requirements, and that we are communicating about all these different components. These are complex projects, and so there's a lot to keep track of and a lot of information that has to get exchanged between our stakeholders at the installations, and then back to us, and then likewise with our contractor partners, who in many cases are the actual subject matter experts in that particular field. And so kind of leaning on that expertise to get to the best outcome is a critical element of what we do, and a large part of what our job is as a PM within the Corps. Chris, the next question was about.
You're also connected with the IGINS counterparts at the various stakeholder component office. They also have their technical leads that you work directly with and are familiar with as well. So you have that interface between the technical side and the community of practice that you guys all connect and share information in through those sessions and meetings.
Absolutely. Thanks, Shanita. Good point.
Yeah.
Jarred one other memory. Another thing that we kind of do from our side here within this geospatial team is hopefully kind of look at the program from a little bit of a higher level at the same time that we're engaged in the weeds of making sure that the right attribute is filled out with the right piece of information on the quality assurance side. We're also trying to understand this IGINS program from a higher level and basically serve as a more or less like a consultant to our these Army and Air Force stakeholders to help them to understand some of the bigger picture programmatic requirements that they may be aware of but not have thought that much about, or had the opportunity to have some of those conversations that Shanita helps mention. So that's a component also of what we do that's important, I think, in our contribution. Let's see, data across host nations versus the U.S. military, the DoD side. That's a challenge, Chris, of course. Luckily, in most cases, we're working on U.S. bases, creating U.S. standard products. So I think about the utilities as one of the examples of a circumstance where we do kind of run into that challenge of maybe needing to gather data or interact with local municipalities or local utility companies who obviously manage and maintain their information in their language under their standards. And no, those aren't going to sync up, straight off the bat from their database to our database. But luckily, most of the type of information that's being recorded and tracked is largely the same from place to place. You need to know what type of pipe is it, how big is it, what's the condition of it, what's moving through it. So those types of things are pretty standard, and I think we have the resources to help do those data conversions when a project requires it. And I think the last question was about UAS, unmanned aircraft systems, Chris, and the level of utilization of that. The UAS program within the Corps of Engineers has been ongoing for about a decade now, and over the past 2 and 3 years, it's something I was engaged with pretty heavily previous to coming out here, but it's come a long ways in that time since, say, 2017 to now. So if you're working projects on the CONA side, probably not on the military installation side, but on the civil work side, UAS has become a very productive tool, and a lot of the districts have now in-house UAS programs, and that's been really beneficial in that most of the data collected from a UAV or what we call a drone, most people might call a drone, an unmanned aerial vehicle. Those are typically going to be really useful for smaller projects, smaller data acquisitions, or something really close in, like a dam inspection or something of that nature. So the UAVs have a lot of really great applications, can produce really high resolution imagery and elevation data, as well as other remote sensing, sensors that could be put on there. But that's not really something that we're working with out here in Europe at these military installations. I think there are a lot of rules and regulations and challenges for doing that work, whether it's from an airplane or from a drone, but it gets more complex when using UAS. And so I would say that's something we've really not engaged with from my side. Like I say, I think if you were to pull in some of the geospatial folks on the more the combat side, you probably hear some different senses of reality. But from our side, that's not a tool that we're actively using. We do fly a lot of airplanes and a lot of have access to helicopters and things of that nature for performing that type of data acquisition.
Thank you. I have an online question from Nick Libassi, and as what would be the best way for potential contractors to learn about the needs that USACE Geospatial may have? A quick search returns sam.gov for general USACE contract. Is that the best place to start?
Well, that's an interesting question. I think the breadth of this program is maybe a little too wide to point you towards one specific resource for what the actual requirements are. Like I mentioned, we're having discussions like this. Maybe this is a good example, having a little bit more engagement from our community out into the with you guys is probably helpful to, if not give you all the information, but at least kind of give an exposure to the work that we're doing. So that's a useful mechanism for maybe continuing this conversation. But I don't know that I have a great answer for you, Chris, on that as far as a specific resource for all the different types of requirements. I would just say basically, if you understand the program, of what it takes to run a Directorate of Public Works, there's a geospatial component across the board. And so if you kind of think of it that way and understand the work that needs to be accomplished, then you could probably do a little bit of research as far as how we're, the actual tools and methodologies that we're applying to meet those needs.
Thank you.
It's more so towards the actions that will be seeking AE support from and resources. Of course, all of that will be issued through the standard process of a task order requirement notification. And I believe every district has some form of submitting that information out to our AE partners for responses to those type of requirements.
Copy. Good, Chris, were you able to hear Shanita add in some value to that question?
I did. I hope Nick heard it too. So, but again, just to respond to Nick, sam.gov is a starting point to identify opportunities to work for the government. So that's a good starting point.
We're our time, but are there any other quick questions or?
From both the live audience and the virtual audience. Going 1, going 2, going 3.
Well, this was really informative. This was really, really good information. And one thing I would like to do is thank you very much.
Well, thank you all for listening and allowing me to come and be here with you guys today. So thank you.
Thank you very much.
All right. Well, I guess if there's any further questions, like I said, I put my email on the slide. It's gone now, but feel free to reach out and ask any questions. And if I don't know the answer, I'll help you to find somebody that does. So thank you.
Thank you.